Department of Mathematics, SNS College of Technology, Palma. So in today's class, we are going to solve eigenvalue and eigenvector. In previous classes, which is solve eigenvalue and eigenvector, there are, I think, two cases we already done, right? In today's class, we are going to have the third case. So this matrix is non-symmetric matrix. Okay, now we are going to solve non-symmetric matrix. Okay, we are going to get the eigenvalues as repeated. Okay, yes, already we done d1, d2, d3. The same cases here also we are going to do, right? So d1 is what? Yes, sum of the main diagonal. So sum of the main diagonals are yes, minus 2 plus 1, 0. Okay, the answer is minus 1. And d2 is sum of the minors of the main diagonal. You can take the diagonal. So for the diagonal, I have to find the minor. So 1 minus 6 minus 2, 0. And second diagonal is 1. Leave the second row, second column. So minus 2, minus 3, minus 1, 0. And the third one is 0. Leave the third row and third column. So the remaining one is minus 2, 2, 2, 1. Okay, this way we want to find the minor. And 1 into 0 is 0 and minus this one is 12. Okay, and the next thing is 0, yes, minus 3, and the next thing is minus 2, minus 4. Okay, so the answer is minus 12, minus 3, minus 6. Finally, the answer is what? Minus 21. Okay, and D3 is determinant of A. Just find the determinant for the given matrix. Okay, just expand the first row. So minus 2 into, yes, leave the first row, first column. So this case I want to find the determinant. Okay, 1 into 0 is 0 minus 6 into minus 2 is plus 12. And the next element is minus 2 into, leave the first row and second column. Okay, so the remaining case 2 into 0, 0 minus 1 into minus 6 is 6. Okay, and the third one is minus 3 because of the element itself you have no mind. Okay, and leave the third row and third column. So 2 into minus 2 is minus 4 and minus 1 into 1 is minus 1. Already one minus here. So minus into minus is plus. And which is equal to minus 2 minus 12 minus 2 minus 6 and minus 3. This one is what? Yes, minus 3. Okay, now which is minus into minus is plus, 12 into 2 is 24, minus into minus again plus 12 and the last is also plus 9. Okay, just add all the terms. So 24 plus 12 is 36, 36 plus 9 is 45. Okay, now replace with the equation. So the equation is what? Lambda cube minus d1 is, in formula we will have 1 minus, in the element we will have 1 minus, minus into minus is plus lambda square and d2 is minus 21 lambda and d3 is minus 45. Actually the equation is what? Lambda cube minus d1 lambda square plus d2 lambda minus d3 equal to 0. This is the actual formula. Just replace d1 as minus 1. Okay, d1 as minus 1, so we will get plus, and d2 as minus 21, d3 as 45, so which is minus 1. Okay, if you solve this equation, synthetic division, I can use the calculator. Okay, so you are going to minus 3 and 5. Okay, so these are the three eigenvectors. Find the eigenvector. So the eigenvector, the formula is what? A minus lambda I into x equal to 0. Okay, in the diagonal you can add minus lambda. Okay, so this equation becomes minus 2 minus lambda 2 minus 3 and 1 minus lambda minus 6 and minus 1 minus 2, 0 minus lambda is what? Minus lambda. Okay, then into x1, x2, x3 equal to 0. And first case is what? Lambda 1 is what? 5. You can take first 5. Okay, then we will move on to the next one. Okay, so just replace lambda as 5. So we are going to get the matrix as minus 7, 2, minus 3, 2 and minus 4, minus 6, minus 1, minus 2 and minus 5. Okay, then into x1, x2, x3 equal to 0. Now you can check the first two rows. Okay. If it is different, you can proceed with cross multiplication. So here it is different. So we are going to have cross multiplication method. You can put. We are going to start with this element. Okay. So 2 minus 4 minus 3 minus 6 minus 7 2. Again, the first and last should be same. So minus 2. You can put the value x1, x2, x3. So x1 by, you can find the determinant for this 2 cross 2. So this is minus 12 minus 4 into minus 3 is plus 12. Okay. Then equal to x2 by, again the same thing, for this we are going to find the determinant. So minus 3 into 2 is minus 6 minus into minus plus 7 into 6 is 42. You can put 42. Equal to x3 by, similar way you can find the determinant for this element. Okay. So minus into minus plus 7 into 4 is 28 minus 2 is 4. So x1 by, this is what? Minus 24, and x2 by, which is minus 48, and x3 by 24. Okay, anything is common? Yes, 24 is common. You can leave 24 as common term. So 21 by minus 1, and 22 by minus 2, and x3 by 1. Okay, you can divide minus also. So finally we are going to get the answer as x1 equal to 1, 2, minus 1. Okay, one eigenvector is over. Next value is what? We are going to replace lambda as minus 3 in that matrix. Okay, which matrix? This matrix. Okay, so replace lambda as minus 3. Already one minus here. So minus into minus is plus. So we are going to get 3 minus 2 as 1, 2 minus 3, 2, 1 plus 3 is 4, and minus 6 minus 1 minus 2, which is 3. Okay. Then into x1, x2, x3 equal to 0. Okay, this matrix we are getting. Okay. Now we can check whether the elements are equal or different. Okay. Possibly it is equal, right? Because you can see it is exactly equal. This is if you divide 2, we are going to get the same thing. Okay. So we can take any one equation which is enough. So first row into first column. So which is x1, 2x2. 2x2 minus 3x3 equal to 0. Okay, we'll have only one equation because all the elements are equal. Okay, so for this type of case, we are going to have substitution method. Just put x1 as 0. Okay, x1 as 0. Find the remaining one. 2x2. Can bring this term to the right. So which is 3x3, and we need to write possibly in terms of the ratio. Okay, so x2 by, can bring this 3 to the left. And x3 by, okay, now tell me what is x2? Yes, x1 is 0, x2 is 3, and x3 is 2. So this way I have to find the eigenvector. Okay, if it is equal, same equation, right? We go for the next substitution, which is x2 as 0, because two eigenvalues are repeated. Okay, so put x2 as 0, which is eliminate this term, and write x1 and bring this term to the right, so which becomes 3x3. We need to write in terms of the ratio. So just bring this term to the left. 3 and x3 by, there is no value in, we take the value as 1. What is x3? Yes, x1 is what? 3, x2 is 0, x3 is 1. Okay, now we got 3 eigenvectors. Okay, if the matrix is which is not symmetric, and the eigenvalues which is repeated. Okay, repeated means this way I want to find the eigenvector. Okay, the remainder will be